Hi guys! So now we're going to look at the different cases for partial fractions. In this class, we're going to be looking at 4 different cases, but in my opinion, they're all really the same thing. Recognizing that the denominator can only be the factors of the original denominators, and that the degree of the numerator has to be less than the degree of the denominator because we'll have started off dividing. So that said, the first case of partial fractions is when the denominator is a factor of distinct or a product of distinct linear factors. Denominator is product of distinct linear factors. And so what that means is distinct means only one time. So each factor only shows up one time. So we're not going to have like x plus 2 squared. Each factor will only be there one time. So an example of this would be, let's say that I have like, I don't know, 8x squared plus 7x plus 1 over x plus 4 times x plus 5 times x minus 2. So each of those factors is occurring only one time, the x plus 4, the x plus 5, the x minus 2. And so I know that they're each going to have their own fraction. So they each get one fraction, x plus 5. And the numerators will just be constants because the degree has to be less. So we use my initials here, A, E, B. Again, it doesn't matter what letters you use as long as you don't repeat letters. So case 2, we're still going to be dealing with linear factors, but case 2 will be the case where some of those factors are repeated. So this is the denominator is a product of linear factors some of which are repeated. So this is where it's going to get a little bit weird to think about. So let's say again, I'm going to keep the same numerator. I have 8x squared plus 7x plus 1 over, let's say that I have x plus 4 times x plus 5 squared times x minus 2 cubed. Well, that x plus 4, same as case 1, it occurs one time, so it gets one fraction. But then when I think about that x plus 5 squared, yes, x plus 5 squared is a factor of the denominator, but so is x plus 5. So this could have come from a fraction that had just x plus 5 as the denominator, or it could have come from one that had x plus 5 squared as a denominator. And the same thing with that x minus 2, it occurs 3 times. X minus 2 is a factor, x minus 2 squared is also a factor. So I'll have x minus 2 plus x minus 2 squared plus x minus 2 cubed. So all of those could be potential factors. So the next thing that's a little bit weird about this one is that the numerators are still only constant. So even with that x plus 5 squared, I'm thinking of that as a linear factor, right? So it's like I had an x plus 5 plus another x plus 5. And then when we add them together, we get x plus 5, or multiply them together, you get that x plus 5 squared. That said, because that division has happened, we're still only going to have a constant in the numerator. That factor is still a linear factor. Okay, so this is case 2. The time when we might not have a constant in the numerator is case 3. So my case 3 here would be if I have a quadratic factor in the denominator. And those quadratic factors will be distinct, so only occurring one time. The denominator contains distinct, irreducible. If you can factor them, then we can turn it into case 1 or case 2. So irreducible quadratic factors. Okay, So what this would look like, I'm actually just going to keep that same numerator. Let's just keep going with it. It really doesn't matter what's happening in the numerator. But maybe in the denominator, I have a 2x squared plus 7. And then we'll still say like I have an x plus 4 and an x plus 5 squared. So in this case, that 2x squared plus 7 occurs one time, so it's one factor of the denominator. The x plus 4 is also one factor of the denominator, but then the x plus 5 squared has a factor of x plus 5 in it. So we're going to have an x plus 5 and an x plus 5 squared down there. So we're always, the number of times that thing occurs is the number of fractions it will get. The x minus 2 occurred 3 times. It got 3 fractions with the power increasing each time. Now, each of these is like before the x plus 4, the x plus 5, the x plus 5 squared. The numerator is going to be a constant. The 2x squared plus 7, however, to have the numerator be 1 degree less than the factor, we need to have an x up here. So with 2x squared plus 7, I'm going to have ax plus b. I always need to be 1 degree less. Then I'll have c, then I'll have d, and then again, remember that x plus 5 squared, our factor there is x plus 5. It's a linear factor, so we're still saying just a constant on top. Now for our last case, case 4, maybe those quadratic factors are repeated more than once. So case 4 would be if the denominator contains irreducible quadratic factors, some of which are repeated. Quadratic factors, some of which are repeated. So an example of this might be, let's go with our trusty numerator, 8x squared plus 7x plus 1. But in the denominator, that 2x squared plus 7 I have is going to be cubed. And then maybe I have another one that just occurs one time. And then let's say that I also have an x squared, because it's going to be important to think about that. So the 2x squared plus 7 is occurring 3 times, which means it gets a 2x squared plus 7. That's one of the factors. 2x squared plus 7 squared, that's another one of the factors. And 2x squared plus 7 cubed is my last factor. Then x squared plus 1 occurs one time, so it only gets one factor. Now this x squared right here, you might think of that as a quadratic factor, and it wouldn't be wrong. It wouldn't be wrong, but it's going to make your life easier in the long run to think of this as a linear factor. So think of it as like x minus 0 squared. So in other words, this is a linear factor that's occurring 2 times. So here we're going to have plus x as a denominator and then plus x squared as a denominator. Now, 2x squared plus 7, that's my quadratic factor. So I'm going to have an x on top. So I'll have ax plus b, and then I'll have cx plus d, and then I'll have ex plus f, then I'll have gx plus h, and then I'll have I, and then I'll have j. Okay, so again, that x squared, you might accidentally put jx plus k, but no, that x squared, we're thinking of it as x minus 0 squared. We're thinking of it as being a linear factor. So I just want to talk briefly again about why that only gets a constant on top. Let's consider if we had thought of this as a quadratic factor. If I combine these two fractions, so in other words, if I do I over x plus j over x squared, well, to combine them, I would multiply by x over x. So ultimately what I would end up with here is ix plus j over x squared, which is exactly what you would have gotten if you had thought of it as a quadratic factor. So the fact that these things ultimately were added together is the thing that allows us to know that when we have them separated, it's still just a constant on the top because it's still just a linear factor. So hopefully that makes a little bit more sense looking at it in terms of the x right there. Okay, so those are our 4 cases for partial fractions. That's all for now.